Lesson 5.4, Long-Term Savings Strategies. The warm-up is completed for you. Please either pause this video and reference my answers with yours, or you may reference the answer key that's posted on our Brightspace classroom. The effect of time on future value. There is an old saying, the best day to start saving for the future was the day you were born. The second best day is today. Essentially, what that saying means is that the longer your money is invested, the more it will grow and the more money you will make. The first day you're born, that would be the longest time period for you to invest your money. On the next page, I've already filled in all of the answers and I'm going to talk about them. So question 1, it says, on the day their daughter was born, Bill and Samina invested $1,000 in her education. Ravit is now 18 years old. The interest earned was compounded monthly and the investment averaged 7% interest per year. Question A, circle the 4 key terms of information in the question. So we need to know how much they invested. So your present value, how much did you start with? $1,000. Okay, and the $1,000 sat in the account for 18 years. And the interest was compounded monthly at 7%. Use a TVM solver or an online calculator to determine the value of the investment today. So I'm going to use the TVM solver that I've attached to this lesson and the TVM solver that we've been using this entire chapter. So here's the TVM solver, and I'm going to input the values. So it's at 7%, and they invested $1,000 on day 1. They are not making any payments. They are just letting that original $1,000 grow. So the payments per month is going to stay at 0. The compounding periods per year, it says that it's compounding monthly. And the number of compounding periods, I'm going to multiply 12 months per year times 18 years. That's 216 total compounding periods. Okay, and then I'm going to solve for our future value. Okay, so $3,512.54 would be the future value of the original $1,000 after 18 years of it being compounded at 7% interest, and that's without adding any additional money to that $1,000. Okay, so I've written down here all the information that we inputted into the TVM solver. And because we're not using the actual TVM calculator, I've just crossed out this end and begin payment. That's irrelevant to the app that we're using. So how much interest was earned is the question in part C. I took the future value, which was $3,512.54, and I subtracted the original $1,000. So it grew $2,512.54. D, how much interest would have been earned in the savings account that paid 0.5% per year? So let's go back to our TVM solver, and we're going to change the 7% to 0.5%. And now I'm going to click solve for future value. And so our $1,000 after 18 years grows only to $1,094.15. So the interest, we need to take away the original $1,000. So really the interest is $94.15. which is the amount that's written here in Part D. So in E, it's asking us to compare our answers, the interest earned in Part C and the interest earned in Part D. So in Part C, the interest is definitely much greater. And that's because the interest rate is so much more. So it's important that when you are investing your money, that you get an interest rate that is as high as possible in order to grow your money as much as possible. Ravit gets a job after high school and decides to let the money continue to grow. Assume that the investment continues to average 7% interest annually. By Ravit's 30th birthday, the original 1,000 will have become, well, let's adjust our values here. So let's go back to 7%. Okay. And now the number of compounding periods is going to change. So we're going to multiply the monthly compounding periods by not 18 years now, but at 30 years. That's 360 compounding periods, and let's solve for that future value. $8,116.50. And that's the value that I've inputted here. So the investment will be worth more than 8 times the original amount. The original amount that they invested was $1,000, and it grew to over $8,000. So that's more than 8 times the original amount. So that means that the longer your money has to grow, the more money you will make. So not only does the interest rate affect the amount of money that you will make, but also the amount of time that your money has to grow will affect the amount of money that you make. Making regular deposits. Gavin is 15 and works after school washing dishes in a restaurant. He has decided to invest $50 per week. He is investing in a fund that has 6% interest rate, with interest compounded monthly. So there's a tech tip here to learn how to calculate future value of regular deposits. So start with nothing and then build for the future by making regular deposits. Using the language of TVM Solver, the present value is equal to 0. The present value would equal to 0 because you're not starting with a lump sum that you're investing at the very beginning. What you're doing is you're making regular deposit payments throughout a long period of time. So the amount of the regular deposit is the payment. Okay, so present value is equal to 0. The payment, PMT, is your regular deposit amount. Your PY, payments per year, is the number of payments made in 1 year and is the total number of payments that are made. Okay, so payments per year times the number of years. And each payment is made at the beginning of each month. And then we solve for the future value. Here's an example. Determine the future value of Gavin's investment in 2 years. So number of weeks in 2 years. So that's 52 times 2 is 104 weeks. The interest rate is 6% because that's what it says here at the top. 6% interest. Our present value is 0, and we're making regular deposits of $50. So your payment, PMT, is minus 50. And we're solving for future value. And then your payments per year is the number of deposits in a year. So he's making weekly deposits, so 52 weeks in a year. And it's compounded 12 times a year. So let's input all this information into our TVM solver. So N is 104, I is 6, present value is 0, payment is negative 50. Future value we're trying to solve for. PY is 52 and CY is 12. Future value is $5,520.84. So after 2 years of $50 payments per week, Gavin will have $5,520.84. Last page, it's asking us to complete the following table. Okay, so again, this is continuing on with Gavin, and let's say that he invests his money for 5, 10, 15, 20 years, all the way to 50 years. Okay, so this is how many years he's investing. This is how old. The second column is how old he would be. The third column is his $50 deposits that he's making. So how many number of deposits would he make? So in 5 years, he would make 260. So you get that value by multiplying the 5 years times 52 weeks, because he's making a $50 deposit once a week. There are 52 weeks in a year times 5 years. Okay, so this 520, that's 52 weeks in a year times 10 years, and so on and so forth. And then you're solving in your TVM solver for the future value according to each situation and how it changes. And you can see that in 5 years, he'll make $15,000. Whereas if he invests for 50 years, he'll make $800,000, which is a lot of money. So you have over $800,000 saved for you. And Gavin would be 65, time to retire. He has almost $1 million for him to retire and have all that money to live the rest of his life without working. B, determine the future value at age 65 if Gavin had invested $60 a week. Okay, so instead of $50 a week, he invested $60. So we can go to our TVM solver. And he's making payments of $60, which is still 6% interest. Still compounded 12 times a year. Still making weekly payments. So at 65, Gavin would be investing for 50 years. So 50 years times 52 weeks per year. So that's 2,600 payments of $60. His future value would be $986,561.34. C, determine the future value of his $50 per week investment, averaging at 8% rather than 6%. So I'm going to go back over here and I'm going to change this to 8% and change this back to $50 and press future value. So that's $1,722,941.46. Lots of money. This is almost $2 million if his interest was at 8% rather than 6%. So in closing, the amount of time that your money is invested is very important. The longer it's in an account growing, the more money you're going to make. Additionally, the interest rate is very important. We can just see here and in part C that a 2% increase in interest made Gavin $1 million, almost $1 million more money. So it's not really about the amount of money that you're investing. What's important is the amount of time and the interest rate. Okay, because here in part B, Gavin was investing $60 per week, but he only made, comparing to part A and part B, he only made an extra maybe $150,000. Whereas the interest rate made him, comparing A to C, made him $1 million more. So every little bit counts. If you can't invest a lot of money, just a little bit will make a big difference. Check out my Check Your Understanding answer. And I encourage you to reflect on today's lesson yourself. And if you want to answer it differently, that's okay too. And don't forget to complete today's quiz. Message me if you have any questions.